Okay, so this video is going to help you graph your Beer's Law results for the blue Gatorade. I've showed you this spreadsheet before, but you do need to use Google Sheets to make this happen. I want you to create solutions A through H, a column for concentration, a column for absorbance. We do want to have concentration on the left and absorbance on the right, because when we graph this, Excel defaults the leftmost column to be the x-axis and the rightmost column to be the y-axis, and that's what we want when we graph our Beer's Law results. So as a reminder, the concentrations that you see right here that I'm highlighting should all be the same for every single group. We all use the exact same stock solution and we dilute it the exact same way. So all of these numbers should be the same for everybody. So if they're not matching right now, please fix them so that they are. Once that's done, you want to plug in your absorbances, your corresponding absorbances that you calculated from the percent T's that you collected from the machine. Your numbers may not match perfectly to what are right here. That's okay. The general gist of it you should be seeing a decrease in the absorbance as we get more and more dilute. I did leave the original stock concentration up here just to have as a reference point in case you didn't write it down, but remember it's 4.446 micromolar. I also have a little spot down here for Gatorade. Remember the Gatorade sample, we do not know its concentration of the blue dye, but we were able to measure percent T and then convert it to absorbance. So I took this absorbance value from a student in another class, and we're going to be using that at the end of this analysis here. So first things first, to graph your results, you're going to highlight these numbers and only these numbers, and you're going to hit insert and chart. This should pop up a nice little scatter plot for you like so, which is great. We can retitle the lab to be, or the graph to be Beer's Law, blue Gatorade. And you want to make sure that your concentration has the label of parentheses M next to it so that we know that it's in molarity. Absorbance is, of course, unitless, so we don't need to do anything for that. And this looks pretty good, right? Every graph should have a title and your axes labeled appropriately. Next, we need to put the line of best fit on and obtain the equation for that line. So to do that, you're going to come over here to the Customize section. If this didn't automatically pop up for you, simply click on the graph, hit the 3 vertical dots, go to Edit Chart, and then boom, this will pop up. We are under the Customize header. You're going to click the Series drop-down menu, and then you're going to click on Trend Line, and boom, it puts on the line of best fit. Scroll down a little bit more, you'll see Label, hit that drop down, and you're going to hit Use Equation. And this is what we were searching for the whole time. We want a calibration curve with a line of best fit, and then the computer here is giving us the equation of this line, which is great. This equation is in the format of y equals mx plus b. So this equation would read y equals 126,904x, and yes, that is a very large number, 126,904x, plus 0.016 as my intercept. So that's what you're going to be writing down. That's the equation that we need. That is the equation of our calibration curve. Once you have that, you can now take your Gatorade absorbance and plug it in for y. Remember that absorbance is on the y-axis. So we are going to substitute in and say 0.205 equals 126,904x plus 0.016. And we're going to algebraically solve for x. X should come out to be pretty small because it is a concentration, and our concentrations, remember, are all in the micromolar range. So you're probably going to get something like 1.3 times 10 to the minus 6, maybe 1.6 times 10 to the minus 6, something around there. From what I've been seeing, the concentration that we end up getting is going to be somewhere closest to solution E, which is good because, again, the whole point of this calibration curve is to create a spectrum of color, and hopefully the blue Gatorade falls along that spectrum of color somewhere. And if it is absorbance of 0.205, you can kind of predict it just by doing, a matching game, rise over run, or an intersection game, I should say. Take the 0.2 absorbance and go all the way over until you run into the calibration curve, and then go down to the x-axis, and boom, yeah, we're about at 1.3 times 10 to the minus 6 molar, right, which is what this point is exactly. Once you have that, you're pretty much done with the analysis portion. This graph is going to end up in your lab report, and this data table up here would also be great to go in your lab report as well. This is going to be your main data and your main evidence in your lab report. You can jazz this up a little bit by closing the borders, make it more chart-like. But what I'd recommend doing is simply just copying and pasting the graph into Google Docs where you're writing your lab report. And if you can copy and paste the chart, great. If not, you might just have to recreate it in Google Docs, no big deal. But that's the gist of it. That's what we're looking for. This will be the main source of evidence and data to support your claim for your lab report.